Hello students. How are you all after so long? I am up with another video today. We are going to learn about chemical energetics. When any chemical reaction takes place that is gain or loss of heat, this leads to formation of either new product or no product. That is where comes chemical and physical change during a physical change. The substance remain chemically same, but its appearance change, that is physical state changes, for example water, which is a liquid, changes into ice. A solid next is chemical change. A new substance is always formed which has different properties than original. One example. Magnesium is a metal when burns in presence of oxygen forms. Magnesium oxide, a new product which is the ionic compound with different properties. Here in this reactions either heat is lost or gained, for example in physical change. Water freezed into solid heat was lost, because of which the water molecules came closer and built a strong force of attraction between them that converted into ice. Here loss of heat is known as exothermic. When in any reaction heat is released or given out in surroundings is known as an exothermic reaction. Energy released, increased temperature of surroundings. When new bonds are formed, always energy is released. In any reaction where heating is involved, it is known as endothermic reaction, for example photosynthesis, where energy or sunlight is taken in by plants to make their food. The temperature of surroundings decrease when heat is taken in. Bond breaking is an endothermic process, as bonds are having strong force of attraction between them. To break them apart, heat is required. Reaction pathway diagram is shown where in exothermic reaction, reactants are at higher energy level, as reactants release energy in surrounding products are at a lower energy level. In endothermic reaction, reactants does not have energy, so is at the lower level and absorbs heat from surrounding, so the product is at higher energy level. The heat content of a system is called enthalpy, which is represented by capital H changes. In heat content is known as delta H for exothermic reaction. Delta H has a negative value, and for endothermic reaction, delta H has a positive value. In endothermic reaction, energy from surrounding is taken in, so surroundings become cool. Similarly for exothermic reaction, energy is given out, so we feel hot. Example bonfire. To make new product, bonds and reactants must be broken. Energy required to break this bond is known as bond energy. For reactions to start, the particles must have energy to collide and react. The minimum energy required for collision is activation energy. Some reactions can occur at room temperature without heating. For example, sodium reacts with water with a spark. The reaction will start when particles will have total energy greater than activation energy. We have a question to calculate energy change in reaction. The reaction is given. H2 plus Cl2 gives 2 HCl. Clear bond is shown between the molecules. So here we have only one bond between hydrogen. We will multiply it with its bond energy given in kilojoule. Similarly, we'll do with chlorine and calculate total energy on reactant side. On right side we have only one product but 2 moles of product, so we have 2 HCl bonds. That's why multiply 2 into bond energy of HCl. Formula for calculating energy change is energy taken in minus energy given out, so we will subtract 678,862, that gives us 184 kilojoule. Then negative value indicates it's an exothermic reaction. In this example, ammonia gives N2 and H2. On left side, that is reactant side, ammonia structure shows nitrogen have 3 bonds with hydrogen, and we have 2 moles of ammonia, so 3*2 gives total 6 bonds of NH. Multiply 6 into bond energy of NH. On right side, we have to product N2 and H2. In case of nitrogen, as we have 1 mole of nitrogen, we will multiply 1 into bond energy of nitrogen. In case of hydrogen, as we have 3 moles of hydrogen, we will multiply 3 into bond energy of hydrogen. Now add the value of N2 and H2 to get the total energy given out of products. Calculate energy change by formula. Energy taken in minus energy given out, we get plus 92 kJ. Positive sign indicates it was an endothermic reaction.